Hello everyone, my name is Joan Batista and this is my solo final project for modeling and analysis of engineering systems. In this project, I'm going to be using differential equations to calculate population growth. The equation that I will be using is dp divided by dt equals kp times n minus p, which is population with respect to time. The equation is going to help me understand how population is going to grow over the next years, and it will also let me know at what point population is going to stop because of the carrying capacity of Earth. The variables of these equations are the following: P, N, and K. P stands for population. This number is dependable of time and it's going to be increasing as we go from left to right. N is carrying capacity. This is the max amount of people that can be carried by Earth. This number is just an estimate since we don't have an exact number for this. And K is the population growth. This number is supposed to be constant, but as we get closer to the carrying capacity, population growth is going to go down, so that number is going to go down. For the first graph, I use the parameters that the article had. This is as time equals 0, population is 6.084 billion, and it's going to be the same number at 12.5 billion. This is the max amount of people that can be on Earth, and K is the population growth. It's going to be 0.04. If we look at the graph, we can see how the population growth starts at a really high rate and it ends at a really slow rate. So we can see how from year 0 to year 20 it grew more than 1 billion. This is because the carrying capacity of Earth is 12.5, so it's really far from this point. But at the end of the graph, we can see how it's getting close to that 12.5, and the growth slows down at a really high rate because it cannot go over that 12.5 billion number. So in the first graph, I used the parameters that the article gave me. Now I want to use a different parameter, so I searched for the population at this point, and I found out it's 7.9 billion people at this point. I will keep the carrying capacity at 12.5, and I'll keep the population growth at 0.04. In this graph, we can see how population grows faster than on graph 1. This is because population when time equals 0 is higher than the first graph. First graph was 6.084. In this graph, 7.9 billion people. And we can see how in the first 20-year population grows almost 2 billion people, but after year 100, which is the second half of the graph, we can see how the population doesn't grow almost nothing. This is because of that carrying capacity at 12.5 that the graph is not going to be able to pass. Some stuff to have in mind is that these are just estimate. We don't really have an exact number of what air carrying capacity is. So we just estimate what the capacity will be, and we estimate how many years it's going to take us to get there. So that's just something that I think we should keep in mind. And this is the end of my presentation. Thank you very much for watching.